Now let's go to indexing and slicing. So indexing and slicing, this technique is used to assess substrains or characters or nucleotides by specifying an index or a range of indexes where you have start and end, and in some cases a step or stride value. So there's a syntax. We have S, that's a string or sequence. We have M, N, that's the starts, and then dash N, and then dash S, that's the step or stride. So let me also use this to explain something. So in Python, counting starts from 0. Okay, so if I have this, let me do this. If I have this sequence, let's I have DNA equals ATC. Let me use uppercase. Now, if let's say I should ask you to find the DNA in position, let's say position 2. In indexing, we can just say DNA and then we give the index value. But because counting starts from 0, the position 2 will have an index of 1. That's how it's going to be. So let's run this. We are going to get Jane. Okay, so this is how indexing looks like. So we can use indexing to do a number of things. We can use that to find patterns or even find or extract sequences, extract particular regions, okay, of a sequence. Okay, so let's look at how to do that. I've covered this indexing and slicing in detail in another tutorial, so I'll encourage you to watch that video. I'll leave the link to that video in the description box for you to check, but for now I'm just looking at it at a glance. So let's start. I have indexing and slicing. I also have negative indexing, which is used to access the last element of a string or sequence. We also have shorthand indexing. We will go through all of these. Okay, now let's start with this first one here. Let's say DNA because let's try any one. Now, if let's say you want to find the DNA, or let's say you want to find the nucleotide in position 3, that will be index 2. Okay, so know that what the counting starts from 0. So the position of interest that you want, you always have to subtract 1 from it, so it becomes -1. Okay, that is if you are making the query from this to this side. So let's say DNA, or let's just say we want the third nucleotide. Let me just use that one. Let's say we want the third nucleotide. Then it becomes DNA 2. Because counting starts from 0 in Python. So the third nucleotide will have an index of 2. Okay, that's what we have here. So this one differs from R because in R, counting starts from 1. So if you are doing R and you are new to Python, it might sound a bit confusing, but it's just a matter of you subtracting 1 from that value of interest. If you want the fourth nucleotide, then it becomes DNA, or the string in question 3. That will be the index. Okay, this is what we have. Let's try out another string. Let's say hello. Let's say string 1. Now I'm shifting from DNA sequence. So if I want the letter, the character in, or if I want the third character, then it becomes string 1, 2. That's what we have here. Now let's try this. We have been using just one value, but what about if you want a range? Then if it's a range that you want, then you have to add the start and then end. So let's go back to our DNA here. Let's copy it. I have this. Let's say I want a DNA sequence, okay, of, let's say I want the range, let's say from the third, I want the third nucleotide up to, let's say, the sixth nucleotide. Then what do I have to do? Let's start. So I said DNA 2 because I want the third, from third to, let's say, sixth. So because I want the sixth, from third to sixth, I need to add an extra value. You know, third will have an index of 2. The sixth nucleotide will have an index of 5. So I'll have to use 2 is to 6. When you specify the query like this, Python will return what? The stats up to whatever you have here minus 1. So in this particular command, we are going to have 2, index 2 up to index 5 being returned. Okay, so this 6 here is more like a boundary so that Python does not go beyond what it's supposed to do. So let's run this command. So we are now going to have AGTA. Okay, so we have the third, which is 2, 0, 1, 2. So 2, 3, 4, 5. Okay, we have 5 here. So if, let's say, yeah, so we had fourth. So there's the actual position. We have position or the third. So I said third to sixth. So that means 3, 4, 5, 6. And that is what we have here, 2 to 6. Okay, so that's what you have. This, you just have to know the rules, the -1 rule, and then after that, everything should be fine with you. So that's how we do it. Let's try again. Let's say we want the second nucleotide up to, let's say, the fourth. So then it becomes DNA 1, 2, 4. We want the second, that's 1. The second to fourth, that will be 3. Okay, so it's supposed to be like this. This is what we actually want. So we add +1 to it like this, and then we can execute. So we are going to have fourth, second, third, fourth. Okay, so that's what we have here. So just make sure to check the documentation for Python, and then you can understand whatever is going on here. Of course, you can also reach out to me if you want the one-on-one tutorial on Python for bioinformatics. So just check the description box. You are going to find my contact there. Okay, so let's proceed. So that's for the indexing and then slicing. Okay, we've done this one where we just specify one value. We've also used a range. Now let's look at the step. This is very interesting, so I want us to look at it. Now let's recreate this DNA sequence, and then let's see. We have a sequence here. Now let's experiment. Let's say we want maybe the first to third. Okay, or let's just say we want, let's say, I think it's better I type this so that we can look at it. So let's do this. Let's say I say this DNA, and I want everything here. I want the interval of 3. That's where the step or stride comes in. So if, let's say, if I take all this DNA, all these nucleotides here, I want to get some nucleotides here, but I want the third. I want an interval of 3. So that means that I want the third of this, the third, the third, the third. So then we can just say, let's say 0, 9, and then 3. I want something like this. So let's run this. Okay, so let's take a look at the code here. So I have 0, 9, 3. So what it means that we are interested in this range, that is 0 to 9. But of course, The 9 here itself will not be included. So in reality, what we are looking at is 0 to 8. So the step here is 3. So that means every third member. So we will start with the first one here, which is 0. That is A. Okay. Now we count 1, 2, 3. That is J. That is what is here. And now we count 1, 2, 3. That is another J. Okay, so that is the step I was referring to. Okay, that's what we have here. So you can always swap or you can change the values to see what comes up. So this principle can be used to generate codons. This is something that I've also covered in another tutorial, but you can check it. I'll leave the link to that video in the description box for you to check. So it is this principle where you have start, end, and step that can be used to get the codons for you. So make sure to check that video. I think it's going to be very helpful for you if you want to learn further. So this is how we use the step as well. Okay, so now we have our indexing and slicing. We have one index, we have start and end. We can also add a step. Okay, so just take note of that. Now let's take a look at that thing here. Let's look at negative indexing. Let's remove these ones first. So negative indexing is used to access the last element of a string. So let's look at how that can be. Let's recreate this sequence here. I'll just paste it. And then let's look at what I mean by negative. So negative index means that the value that you are using, I mean, we specify 2, 6, 4, etc. We make it negative. So with negative indexing, let's say DNA -1. So with negative indexing, counting starts from 1. We don't use 0, we use 1. So if I want the last element, then it becomes -1. So that means I'm starting the counting from this side. Okay, so just like how we have 5' and 3' for DNA sequencing, then sometimes you go from 5 to 3', sometimes 3 to 5'. Okay, so we have something like, so if I want the last nucleotide or the last character, then I can use this to get it. So let's see how we get it. So it's A. What is the last? Of course, here if we have A and A, let's just use this to get started. Let's change this one to T. Now let's do it again. DNA 1. Okay, so we have T. If you want this one, okay, the nucleotide just after the last one, then of course you have to use 2. So you can say -2. So that will give us gene. Okay, now let's try something. You can also use this technique to also get the reverse sequence as well, but that's something that we are going to look at in the next session. So you can also do this. So let's do this. So let's say DNA, I start with, let's say 4, I bring my colon and I say -1. I'm going to get some values here. Okay, so that is also possible to do that. Okay, so let's proceed. Okay, I have a message from Osvaldo Rodriguez. Okay, so thanks Osvaldo for the message. Yeah, so just make sure you learn some stuff. So I think this live stream, I'll be doing it weekly, by the way. So Tuesdays will be for Python programming, Wednesdays will be for Linux or Bash scripting, and then Thursdays will be for R. So just make sure to come and then join the live stream. So before I proceed, I also say that with the timing, it's still experimental. So I'm trying to look for the time that works for a lot of people. because of the time zone. So just let me know what you think about the time. Initially, I said 3 p.m., but then later on, I made mention it's going to start at 5 p.m. So I'm still experimenting to see the time that will work for most people. So just make sure to join and then learn something new. And again, the notebooks and everything will be made available. So just check my Patreon channel, and then you have access to all my materials, not just the program material, but for the YouTube tutorial that I make, I put the bash scripts and everything in Patreon. So just make sure to check the Patreon and then just check them. I'll later give a video that describes the Patreon system that I use, because there are levels or tiers. So just take note of that. Okay, so let's proceed. So we were on the negative index. So that's what we had. Yeah, the earlier one, there were some errors. So you can also do something like this. So you get from position 4 to the last one. Okay, there are advanced queries you can make. This tutorial is the introductory one, and so there are things that I may not be able to cover for now, but I hope this tutorial is going to serve as a starting point for those who want to learn programming. Thanks for joining, all of you, and then just make sure to learn some new stuff. Okay, so let's proceed. So that is for the negative indexing. Let's try this. Let's try this if it will work. Let's try another experiment here to see if that will work. We are experimenting, and then I'll see. So this time I'll say -4 to -1. Let's see. Okay, perfect. That has also worked. Okay, so that means that the earlier errors I made, I should have rather started with this and then ended with this. So I think it's fine. I've also learned something new here. Okay, so let's proceed. So there's for a negative index. So here we are starting from 1, 2, 3, 4. This one here up to G. Okay, again, the limiting or the boundary still persists. So that means if I have -1, it's -2. That will be the last nucleotide that will be returned to me. So that is why I have this here. Okay, so let's proceed. Now we will continue. This is for negative index, and we also have shorthand index, which is also here. Let's try this. So shorthand indexing is done by omitting either the first or the last index. So I have some shorthands here. So we have this one here, start the slice from beginning of the sequence to index just before, and we also have this, and that. Okay. So I think this one, let me just remove this one. This one was an error. I will change it. We use this one. It's rather -1. Yeah. So let's look at the shorthand indexing. So I made mention it is done by editing the first or last index. So we have some shorthand indexing techniques here. So we are going to look at all these ones here. So just down the notebook and you find the statements also there. So I have all of them here. Yeah, so let's try the first one. Let's create our DNA sequence again. I will paste here, and then I will use that. So let's start with the first one. S is to N. So in this case, it becomes DNA. So let's say S is to N. Let's say 5. So that means that Python will return all the nucleotides starting from the first in index 0 up to index 4. That's what this statement means. So let's run this. So we have this. So we have 0, 1, 2, 3, 4. We have A, G, T. Okay, so we are starting everything. Okay, so notice what we have here. We have A, G, T. 0, 1, 2, 3, 4. Okay, that's the index. Okay, here again the -1 applies. So even though we have 5, it's going to be 0, 1, 2, 3, 4. That's what we have here. Let's do the second one. So I'll say DNA, let's say 5. So here we are going to start from position 5 up to the end, the last. That's what this one means. So let's run this. So we are going to start from here up to the last, which is here. So 0, 1, 2, 3, 4, 5 position. Let's do it. 0, 1, 2, 3, 4, 5. That's A. Okay, this up to the end. That's what this other one means. Now let's look at this one here. This one, what's DNA? This will return a copy. So to return basically a copy of the sequence of interest. Okay, the sequence that we want to make the query on. So it's just a copy. Now let's look at this one here. This returns the reverse of the entire string. Okay, so that one is S, let's say, yeah, DNA, and I have this -1, and this will return a copy as reverse. So that's what you have here. Now let's type DNA. That's what we had, and now let's look at DNA, this one, that's a reverse. Okay, so I have that also here. Okay, so that's what I have. Okay, so this will return the reverse for us. That's the reverse sequence. So the reverse sequences, I've also covered them in detail in another tutorial. So just to the description box, you'll find the link to that video there. Okay. And for these things I've done, I've made, for some of the sections, some of the parts, I've made detailed videos on that. And so if you want detailed explanation, then just check the appropriate video and then use them. Okay, so this for the other one. Now let's check